Okay, so we've got this region R which we need to rotate around the x-axis. And we've got to work out a bit of a clever way of doing that because we haven't just got one function defining R because R is bounded by two functions or two curves. So I guess the way that we're going to do that is if we draw in a line like that, a dotted line, and we'll be able to work out that x coordinate later on, then we're going to imagine rotating this green region, so the whole region, up to the red line around the x-axis. So you can see that if we do that, then our solid is going to have too much area because we want to remove this white area and what you'd get if you rotate that white area around the x-axis. So we're going to work out that green area rotated around the x-axis, get the volume of that solid, and then we're going to subtract this red area volume when it's rotated around the x-axis. So our first job is we're going to work out the point of intersection of these two graphs. So intersection. So when they intersect each other, we're going to have root x is equal to 1 over 8x. So this is a fairly simple and straightforward equation to solve. We'll times through by x, so we're going to have x to the power of 3 over 2 on the left hand side and an eighth on the right hand side if we times through by x. And then you should probably be able to spot that x is equal to a quarter, but if you can't spot that, then we could think, what do I need to raise the left hand side? What power do I need to raise that to in order to get x to the power of 1 on the left hand side? That's what we're aiming for. Well, whatever power goes here on the outside of this red bracket, we would times it by 3 over 2. So we want to put 2 over 3 on the outside of this bracket because when we times those two together, we get 1. And if I do that on the left hand side, then we'll also have to do the right hand side to the power of 2 over 3. So we're going to get x to the power of 1 on the left hand side, and if you do an eighth to the power of 2 over 3, you do indeed get 1 quarter. So we can label that on our x-axis, that's a quarter. So the first thing that we're going to do is we're going to rotate that green area that I drew on around the x-axis. So the green area is bounded by this red curve here. So we've got this red curve here with the equation y equals, I'm going to write it as x to the power of a half, or y equals root x. And we're going to rotate it between x equals a quarter and x equals 1. And we're going to rotate that entire region. And it's worth noting the solid that we're going to get is going to look something like that. So we've got to be careful that we use the right formula here. We're rotating around the x-axis, so the formula is the integral of pi y squared dx. And our limits, we're going to rotate between x equals a quarter, that's the start of our region, and x equals 1, that's the end of our region. So we can take the pi outside of the integral and sub in our y value. It's really important that you use the correct y function because the edge of our region that we want to rotate is this function here, root x. We're going to use that one. So y squared is going to be x to the power of a half squared dx, and we're going from a quarter up to 1. So if we work that out, we're going to have pi integral of x dx between a quarter and 1. So if we integrate that, we're going to have pi times by, the integral is going to be a half x squared between 1 and a quarter. So we're going to have pi times by, sub in the top limit, and we're going to have a half minus sub in the bottom limit, and we'll have 1 over 32. So our volume of that green area, when we rotate that green area, is going to be 15 over 32 pi. So next we need to work out what volume do we get if we rotate this red area up here around the x-axis. and we need to subtract that volume from the volume that we got before. So in a way, we're kind of imagining rotating this red area here around the x-axis, and we're going to subtract that, and it's kind of going to hollow out that shape that we made and make a ring shape. So let's draw a little sketch. We've got our function 1 over 8x, and we're going to rotate between a quarter and 1, and we're going to rotate that red area around the x-axis. So we're going to use the formula pi integral of y squared dx, and we've got to be really careful. This is our equation for y now, because this is now the boundary of the red area that we want to rotate around the x-axis. So we're going to have pi integral of an 8th x squared dx. So we're going to have pi integral, I've forgotten the limits of my integral, from x equals a quarter up to x equals 1. So we're going to have 1 over 64 x squared is on the bottom, dx. So that x there needs to be on the bottom. So I'm going to take the 1 over 64 out, so I'm going to write it as pi over 64, and then I need to integrate 1 over x squared. So integral of 1 over x squared is the integral of x to the minus 2. So if I increase power by 1 and divide by the new power, I'm going to get minus x to the minus 1. So then, if I sub in the top limit, we're going to get minus 1, and then we're going to minus, what do we get when we sub in the bottom limit? Minus 4. So we're going to have 3 pi over 64 for that red volume. So finally, all we need to do is we're going to take this volume that we got here from this shape, and we're going to take away the volume that we got when we rotated this red shape. So the volume that we want is going to be equal to 15 over 32 pi, subtract 3 over 64 pi. So we'll get 27 over 64 pi.